Yeah. So this is the main topic of HVAC, right? Like heat load calculation, heat and cooling load calculation. When we start. So two things are there. Either you can go for cooling or you can go for heating. Cooling for summer condition, heating for winters season. Okay. So here two things are there. Like if you consider any space, okay, outside some heat will be there. Okay. If you consider about the summer season, some heat will try to enter into your space, right? In that case, what will happen? More heat will transfer from outside, the heat will transfer to inside, right? And similarly, a lot of equipment, if you consider any office space, okay, or any hospitals, so there you will have a human being, they will generate a lot of heat, right? And a lot of equipment like if you consider office space, like equipment like electronic devices, like your laptops, your printers, those will generate a lot of heat. Some electronic device will release some heat, right? So a lot of heat dissipation will get it through that. And some business appliances and some kitchen appliances. Business appliances, as I told, laptop, computer, CPU, okay, and your printers. For kitchen appliances, it is like your coffee machine. If you have any cafeteria and all, there you will have coffee machines. Okay, so that will generate a lot of heat. So all these things we will add like external source. So what all the heat gain through external source? We'll find out. We have a lot of options. We will go step by step. Similarly, a lot of inside internal source like people, lighting, and appliances. Right. So light also will give a lot of heat. Similarly, vice versa for winter season. So outside a lot of cold will get that will try to transfer inside. Okay, so you have to use the heating process like boiler or heating the thing. Okay, heater. The concept is remain same, but the process changes. The vapor compression cycle, what we learned. Okay, in terms of heating, it will be reverse vapor compression cycle. Same component will be there. Compressor, condenser, expansion, evaporator, but the cycle will reverse. So far clear? Is it clear?
Yes, sir.
So cooling, as I mentioned, cooling and heating depends on the type of uh, season. Based on that, you can go for some building. You can go for like VRF we discussed. Okay, you can go for hybrid system. Okay, in some season you can use the same system for heating, in other season for cooling. So hybrid option is there, right? So if you consider a space, okay, outside some air will enter and inside we have to maintain 76 degree and some heat will we have to remove, right? If I take an example of a bucket where you want to fill the water up to this level, a certain amount of water will enter here, water in. Okay. And certain amount of water, it will be out. And water is in this level. So at what condition your water will remain same? It will not increase or decrease. At what condition? Can anyone tell?
Or in is equal to out.
Right. So water in equal to water out. Okay. If this is the condition, then you can maintain the level of water. Right. Similarly, in case of heat, if what all heat or cool cooling you get it from outside, if you want to maintain certain temperature, this temperature is as per ASHRAE, right? You have to maintain this temperature. If temperature is more, human being will feel uncomfortable. You understand, right? The concept of air condition. Temperature is more, people are uncomfortable. Temperature is less, people are uncomfortable, right? So ASHRAE, American Society of Heating, Refrigeration, Air Conditioning, okay, they are a governing body. They have given the standard temperature. This is the standard temperature. Of course, there is a tolerance of 2 to 3 degree, which comes around 25 degrees Celsius. So plus minus 2 or 3 you can variation you can do. Right. Avan, this is your first session, right?
Yeah.
Okay. Okay. So are you able to understand? Because it is the mid
Yeah, I have
session.
experience like in Nepal, so I know all this
Oh,
process.
oh, okay. So have you worked in this system or how about it?
In HVAC system, yep.
You have worked. Okay, great.
Yeah.
So presently what you're doing?
Now just like I recently came here like 2 months ago.
Hmm. Okay, fine. Thank you. So moving on. One thing about all I mentioned. So you have to maintain the desired temperature and thing. Now source of heat gain. We have two source of heat gain as we discussed. This is what this scheme is given just to make you understand. Right. So outside some heat will try to enter the space, and inside you have people, lighting and appliances. Outside you have this radiation, heat radiation, which will try to transfer through. If you have any glass partition, it will enter. If you have any wall, roof, to floor, to partition, all external source that will try to enter. So what we will do, we'll add all the external source, okay, of heat gain and what all the internal source. So how much heat gain we are getting it, based on that we will design. We will get the tonnage. How much heat will generate means what is the unit of heat? Sorry, and that not heat, not temperature, right? Remember.
Joules.
Sorry, Vivek, we're telling something I'm not able to
I
understand.
said joule.
Joule.
Unit of
Okay. 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 Uh, Joule, calorie, and even but in HVAC we only follow BTU. BTU is thermal unit, right? BTU. So what we will do, we will find out what all the heat generated by all this equipment and all. So you know how to convert the BTU into TR. So 1 TR, how much BTU?
$12,000.
Mhm. Okay. So based on that, if you get it, for example, you got 36,000 BTU you got. So you can understand that you require 3 tonnage. Got it? So based on that, we will, so I'm just giving a broad idea. So we'll go step by step. So what are the external source? Like heat gain through glass, through conduction. Okay. Mode of heat transfer. What are the 3 mode of heat transfer we learned?
Conduction, convection, and radiation.
So here heat gain through conduction. Okay. Conduction means if you touch the wall and or a glass, you will feel the heat. Okay. And the radiation. So outside through radiation also some heat will transfer. Remember for glass, we will go for conduction and radiation. Okay. Even for skylight, for a small example is given just for understanding skylight, conduction, radiation. Whereas for wall, door and all other thing, you have to go for sensible heating. Okay. And partition, which will be the conduction, which will be sensible heating. Clear? Ventilation and infiltration is convection. You have to remember this concept. Simple. For 3 things are there. One is your wall, and another thing is your glass. Then you have a air, outside air. Outside air also will try to enter your space. How? Through your door and window. Okay, they will have some gap between this. That is called door undercut. Okay. That outside air will enter. So for wall, you have to go for conduction. For glass, you have to go for conduction plus radiation. And for outside air, so this air, right? So for you have to go for convection. And convection means you will have both sensible and latent heat because it is a moisture, right? Outside air. So air contain moisture. Okay, so it will have sensible plus latent, whereas here you will have all sensibles. Here, as of now, so step by step, we will go through to find out the external source, and then we'll add all this. What are the total external source? What is the total internal source? We'll add and we'll find out the this thing. Internal source, lighting, people, appliances. Lighting will be sensible, people will be sensible plus latent. Yeah. Next, you have internal source of heat gain already, which I told, which is mentioned here. Okay, so moving on. So business appliances will have only sensible, whereas for kitchen appliances will have sensible plus latent. Because, example, you are making a coffee, so it will convert into steam, right? It will generate a lot of heat. Okay, so for that reason, we are using latent heat. You know, right? What is sensible heat and latent heat? Latent heat means change of phase. Okay, if you make a coffee, okay, some amount of milk, it will vapor, right? Change of phase happen from liquid to vapor. So because of that, we are having a latent heat. Similarly, human being, okay, whenever you do any exercise or something, some amount of heat will generate. Okay, it will be both sensible and latent heat. Whereas for ventilation, any air related things, what is ventilation? Ashish, Mukesh, Vivek.
The passing of air outside.
Outside air. Yeah, Ashish, please.
Removing the bad smell and from the furniture and computers.
Right. So to remove the any bad smell, okay, and provide the fresh air from outside. So air, it contain moisture. So what type of heat will generate? Sensible and latent heat. Here, the same here, infiltration also. Infiltration, we make a note. Unwanted air which enters through door, window, that is infiltration. Clear? Next, when you refer any condition, okay, any city temperature, we will have three parameters. Okay, one is for comfort, 0.4. Yeah, it will be mentioned like 0.4 dB. Okay, which are dry bulb, this is wet bulb, 1% dry bulb and wet bulb, dry bulb, wet bulb. Okay, so here this is designed for comfort and this is for balancing, this is economical. What does it mean? Comfort, balancing, and economical. Comfort means the priority is given for the comfort level. Okay, so here you will get more tonnage. Tonnage will be more in comfort, right? In economical, for example, one space I designed considering this 0.4 comfort design. So I'm getting 3 TR. If I go for 2%, I will tell in example in detail, but for the uh, just for basic understanding, just understand that for economical, the tonnage will be less. So here in the same space, you will give 2 tonnage. Okay, balancing is in between that. Okay, just I'm taking a small space, so it is 3. In balancing, you can take mid-range of tier. So as a designer, you need to select what is your priority. You want to go for comfort, you want to go for balancing or economical as per your design. Is it clear? Now, let me show this. So heat, to find out the heat, we have a formula. Okay, where Q is total heat generated, you will get it. Q is your overall coefficient of heat transfer. Means if I consider a wall, okay, how much heat it will transfer. For example, this is 9-inch wall. If I consider a 9-inch glass, the amount of heat transfer will be different, right? So that you will find out from U value. U value of glass will be different. U value of wall will be different. You have to find out the U value. Correct? Area of the wall, the temperature difference, outside temperature minus inside temperature. So this is the formula you should remember. Is it clear? And U is equal to 1 by summation of R. Summation of R means What is your summation of R? Is your resistance, heat resistance. Heat resistance. Okay. So these all value you will find out, or you can take it from the table. We have certain table you can directly use from the table, or just for understanding, I will tell you how to do it for one, and remaining you can practice. Can you see my screen? Same thing it is mentioned here. U is overall heat transfer. Okay, the unit is BTU per hour. Okay, square Fahrenheit degree. Square feet degree Fahrenheit. R is the thermal resistance of the material. U is equal to 1 by summation of R, where summation of R is equal to, I'll tell in detail. Right. So, okay, summation of R is equal to let's change the color. Yeah. So if this is the wall, okay, outside some air will come and it will create a layer, right? Similarly, inside, so R outside, R inside. For example, if I want to find out the resistance for the wall, okay, so R outside plus thickness of this, okay. If you have any plaster, okay, you have a brick. If it is 9 inch, so 8 inch is the brick, half inch cement plaster. So H1, X1, R1. X1 is the thickness of the cement plaster. R1 is the resistance of the cement plaster. Then brick X2, R2 plus again another layer of cement plaster X3, R3. Then inside Ri. Once you get the summation of R, you will take reciprocal of summation of R. You will get U value of any material. Clear? But you have to find out the resistance value of each, like brick, plaster, whatever. Is it clear? All of you? Ashish, Vivek, Mahesh, Mukesh,
Yes, sir.
Yashwant, all are clear?
Yes, sir.
So, so our resistance means thermal resistance, or what is it?
Yes, it is thermal resistance.
Okay.
Okay. And we have certain outside, okay, outside and inside values, resistance value that we'll find out. Already the standard value, we'll add that value. That's it. Okay. So now this is 9-inch brick wall. Okay. So as I told, R0 outside air, X1, X1, R1. X1 is the for cement plaster. X1 is half means 0.5. R1 is resistance of the cement plaster. Resistance of the cement plaster is 0.12 plus 8-inch brick. 8 into resistance of the brick 0.2 plus you have cement plaster 0.5 half inch into what is the resistance plus inside. To add all the value, you will get 2.18. U is equal to 1 by 2.28. You will get 0.37. This is a type error. 0.37 you will get it. So what does it mean 0.37? 0.37 means 37%. which means if outside you have 100 BTU, imagine you are having 100 BTU outside. Out of that, 37 BTU heat will transfer inside. Okay. Similarly, for the glass, you see 0.25 inch of glass. So glass will have one layer of air, and the thickness of the glass. So R1 plus X1 R1. This is Ri inside or outside plus R whatever. Okay. So these three things you will get. So R inside or outside value, you know, thickness is 0.25 and value resistance of glass is 1.25. So if you add, you will get U value summation of R U is equal to 1 by summation of R. You will get the U value. Clear?
Yes, sir.
Okay. So similarly, you can find out some values. You can change it. Like certain case, it is taken a standard value. Okay, this is the standard value 0.25. It is taken. Some case you can take it 0.3. Okay, in US, in our case, we can take 0.3, or you can design for 2.25 also, not a problem. But if you want to go for specific, okay, some people they take it 0.35, and some people they still consider 0.25. Some people consider 0.33. Okay, it does not make much variation, right? So in that way, you can calculate. 7-inch floor, wall, and ceiling. Similarly, you can calculate. Okay, but floor. Floor means what all the things you have. See, all these things depend on the type of construction. You need to see the architect drawing what type of construction it is, and based on that, you need to design. Like you have a floor, so you have a concrete and some plaster and tiling. You have, right? Different layer you have, correct? So here same layer is given, like the thickness of this 7-inch floor means 5-inch will have a concrete and 1 inch in some plaster. Okay, some plaster you'll have. So all the value it is taken here. 0.5, 0.5, this is 5. So you will add, you will get this. Here extra 0. Here, same way you have to verify for other. So for roof, for partition, for skylight, for door. Clear? So you see an example here. For roof. Similarly for 4-inch partition, 5-inch, 1/2-inch. Skylight, doors. Like this, you need to find out the U value. Clear? How to find out the U value? So these all value what we got it. We will use this in our project. Next, area. So this is our project. This is our project. So you have two space. One is ground floor, another is first floor level. So this is your office space. Okay, we have considered commercial so that you get to understand a lot of other scenarios. So office space, 4 people are working here. So number of people is 4. Okay, and area, location, everything I'll give it to you. So north wall, you can see this is orientation. You can see north is this side. This is west, east, south. So north wall, this is the, so what is the length? 10. What is the height of that? 10. So gross area is 10 by 10. Getting it? 10 by 10. If I draw this section, this is 10, it is 10 feet, and in between you have a window 5 feet by 4. Clear? This side section, one section I did. If you stand here and look this side, so you'll see this. Is it clear?
Yes.
Ashish, Vivek, Mahesh.
Yes.
Yeah, it's clear. Similarly for the west side. Okay, another thing, net area. What is net area? So net area, gross area is 10 by 10 is your 100. Net area is 100 minus the window. Window is how much? 5 by 4, right? 20. So 100 minus 20 is 80. Clear? Similarly for the west wall. West wall, if you see, this length is how much? 15. Height is 10. So 15 into 10, 150. And the net area is how much? 150. You need to subtract this value. 7 into 4, 28 plus 21, which is 49. So 150 minus 49 is 101. Clear? Similarly for the south wall. Okay. For south wall, 10 by 10, there is no window and everything. So net and gross both are same. Partition wall, this side is a partition wall. Okay. Height, this is 15. Height is 10. So 150 net both are cross. Similarly, floor area also same. Roof area. So here you see this is one room. So our project is this. We are not consider this space. We are learning for this space. So only roof is this one. So roof is this one. Okay. So 6 feet by 9 inch is the roof area, and we have a skylight of that. So what is the and height? You know, will be 10, right? So 6.75 into 10 equal to you get this. Okay, now 6.75 have you got it? So here 9 inch is there. 1 feet, how much inch?
12.
12. So 9 by 12 if you do, you'll get 0.75. So 6.75 we got it here. Got it? So this is your total gross area. Net area is this minus this skylight. So we get net area. Clear? Ceiling area. This multiply with this, so we get the ceiling area. So we get ceiling area. Clear now? Now, anyhow, when you are doing manual calculation, okay, we will use the net area. When we will do HAP, it will automatically, we will use the gross area. So the software automatically subtract this and take the net area. Okay, which is very easy compared to a manual one. Manual is just for learning the concept. Moving on, as I told the project. Okay, so location, space, number of people, height, latitude, longitude, temperature requirement, you can check accordingly. Okay, what type of glass thickness? 0.25. Already we got the U value, glass type, latitude, longitude, elevation, number of walls. Okay, this may change as per project to project. So now we'll find out the heat gain. Okay, external source we'll find out. Okay, you remember the list what we have? External source for lighting, sorry, for glass. Then we have a wall. Okay, For glass, you have two things, one conduction and one is radiation. For conduction, you can add the two wall. For radiation, you cannot add the two wall because orientation is different. Okay. Next, we'll go for wall. Then roof, floor, ceiling. Okay. After that, we'll find out the ventilation, infiltration. That these are the external source of heat gain. Okay. So first is heat gain through glass. The formula is same. U is equal to UA del T. U for the glass already we got it. What is the U value for the glass? 0.8. What does 0.8 mean? What does it mean? 0.8?
8% of
80.
heat.
80, not 80.
Yes.
80
80% of heat is
transferred from outside to
Trans-
inside. Okay. We are designing for summer condition. So this area W1 plus W2 if you add 20 plus 28, 48. And here you are adding because of the conduction. In conduction, we'll add the window. Whereas for radiation, will not add. So del T is equal to T over minus Ti. So outside temperature is how much minus inside temperature, you will get this. Okay. So as a result, this is the value you will get. This value may change from project to project, just by understanding the concept. Okay. Similarly, for radiation, you have to take two values, one because of the orientation. So we cannot add the area because orientation is different. So UR value we will get it from the table. Now for radiation, here we are using ordinary glass. So the value is dark color if you are choosing 0.75, 0.75, and this table is from carrier. Okay, and for north, U value you know, area you know, area was how much? Area of the north, that is mentioned here for the glass, 5 by 4, 20, right? Latitude, longitude, all these things you have to find out. And okay, another thing, we have to find out the del H here. In case of radiation, it will be instead of del T, it will be del H. It is called del H. Okay, so del H will find out from the orientation. So north, so we have north, okay, and latitude is this 28.56, which is 30, almost 30. So table number 15, solar heat gain through ordinary glass. And this is the time of the year. And mostly it says you need to consider for the May month. This is the scenario. Two timing we have to consider, 8 a.m. and 4 p.m. Morning time, each side will be affected. Evening time, 4 p.m. This is the timing generally as per ASHRAE. Okay. So 30° north latitude in the month of May, 8 a.m. or 4 p.m. So based on that, we find out del H is 14. Right? You can see here for the north orientation exposure, we have 7 p.m., 8 a.m. and 4 p.m. Both are 14, so you take 14. So 14 is del H. So if you multiply, you will get the value. Next, similarly for the west window, we will find out, and for the west, evening 4 p.m., you will get the highest temperature, you can see here. So that value you put it, and already you know the area of the window, right? 7 by 4, 28. Okay, so this value you will find out. Clear? U value already you know, area you know, del H will find out from this table and use it. Clear till now?
Sir, what is the physical meaning of that H?
Heat. Okay, del H is heat gain.
Okay.
Okay.
And Q is also heat?
Q is total heat. So this is per unit. Okay, if you multiply the area and U value,
Yeah.
total, you will get the total heat. Q is your total heat. This is per square feet, you can see, right? Unit.
Okay.
Yeah, this is per square feet. And here you have multiplied with, like, for example, yeah, here you see per square feet and we have 28 square feet. If you multiply, you will get for total area, right?
Yes.
So you are getting this total area. So this square feet is cancelled. So you'll get the unit is BTU per hour. Similarly for the skylight part, so conduction and radiation. Okay. Conduction, outside minus inside. Radiation, del H, you will find out from the thing. Clear? U value already you know for the skylight. A 2/2 4 del T outside minus inside. And here for the skylight, we are going for no shade. No shade means you will have 1. Okay, no shade 1. U value is 1. Area is 4. Del H you will find out from the table based on the orientation. So it is roof on the roof. So afternoon generally it is on the noon time where maximum temperature you will find out. So 246 is considered here. Clear? So using all this parameter, you will get the values. Any doubt in this? Till now, glass and skylight both are same. That is one category. Like glass and skylight is one category. Then we'll have a wall, one category. Then third category is your ventilation. Next is your wall. Okay. Now, wall has a minor modification. Okay. Here we are going for sensible heating. Now, formula is same. U and del T. And for wall, if this is your building, so orientation wise, you have to find out the heat gain. So orientation wise. So I have taken the north wall here. So north wall, the area was how much? If you remember, 10/10, 100 minus the 5/4, 20. If you subtract the window, you get 80. So it is the area. And U value, we got it previously. And we'll find out the del T. Here, del T value. Okay. So del T is equal to equivalent temperature plus correction factor. All space, all area except New York, you have to use the correction factor. Any space area you go, any location you go, except New York, because the temperature and climatic condition, what is mentioned here in this table, it is for New York. Any other place you are designing, you have to consider the correction factor. Safe. Okay. And if you're designing for New York City, don't consider the correction factor. Because this temperature, all these things comes under New York City, for New York City. Clear? So now how to find out the equivalent temperature and correction factor? Step by step we'll learn. So this is the table number 19 from Carrier. Equivalent temperature difference. Orientation is our north. Orientation. So north shade. And here it has some weight of the wall. In our case, we have 9 inch. So if you convert the 9 inch into pound per square feet, it will be almost 100 100 pound per square feet. And timing we have to see. So timing, if we draw any space, okay, timing will be like 4 p.m. 4 p.m. we will take the timing. So 4. So 4 you will get the equivalent temperature. Okay. Generally midday plus 2 hours you have to consider for the timing. Clear? Any doubt till now? Equivalent temperature. Up to equivalent temperature. Is it clear? I'll go for the correction factor next. Please confirm. Ashish, Vivek, Mahesh, Mukesh, Vishwan. 1.
Yes, sir.
Now correction factor, we have to find from the table, and before that we should know the range. Okay. We will get it from the psychometric condition range. What is the range? You see maximum temperature of the day and minimum temperature of the day. So that is the difference, is the range. For example, maximum temperature is 20 degrees and minimum is 10 degrees. So range is 10 degrees, right? Okay, I'm showing in Celsius. You can convert into Fahrenheit as per the requirement. Now our temperature difference, outside temperature minus inside, how much you have to maintain. Okay, outside is 109, inside is 76, you will get 33 degrees Fahrenheit. So based on that, okay, correction factor it is not shown. I'll show you the table one. This is the handbook, carrier handbook, which you have to refer. Door. Then you go for equivalent temperature, then correction factor. So for correction factor, 2 things we have to find out. We should know the daily range and then the temperature difference, outside minus inside. Okay. Based on that, how much you are getting. In our case, daily range was 18 and temperature difference was 33. 33 is here in between and daily range is 18. So both fall in between here, 16 to 21. So almost 18 or something it will be. Right? 19. Clear? Can you see my screen? So once you find the correction factor so it is same for throughout the project. Now for waste wall, U value, A value, del T value, equivalent temperature plus correction factor. Correction factor remain the same for throughout the project. So you have to find out the equivalent temperature. For waste orientation, expose your waste. You see time 4 p.m. and we are taking 12. So 12 plus 19 is 31. If we multiply, we'll get total BTU per hour. Is it clear till now? Similarly for the south, similarly you'll find out this correction factors remain the same. Equivalent temperature is 16. If you multiply, we will get the total BTU. Clear till now? Any doubt?
Yes, sir. Clear.
I'll share the this carrier handbook. So all the reference you can take it from that itself. Next, heat gain through wall, partition, floor, ceiling. Okay. Wall we have completed. Now for the partition. This is the partition. U value already we got it previously. A 15 by 10 we have, and del T. Del T is outside condition minus condition space. Outside unconditioned means where, for example, you are not using any AC in other thing. Okay, we don't want to use it. Okay, this is just outside. So we don't know the temperature. For example, one kitchen is there. If you decide one cafeteria or kitchen is there, then you have to consider the temperature higher. Okay, imagine two scenarios there. Like this is our project here, and this is the partition it is shown here. We're not going to cool. Just example. Okay, we are not going to cool. That is one scenario. Second scenario is it is a kitchen. Okay, so in that case, what will be the thing? If you are not going to cool, the temperature here will be outside temperature minus 5, which is considered here outside condition, unconditioned. And inside you are maintaining 76. So 104 minus 76, you will get some value. Now, if there is a kitchen, so outside unconditioned will be outside how much? It is not there. Please make a note. If it is kitchen, outside plus 10 degree Fahrenheit. So outside is 109 plus 10, 119 minus 76, whatever you will get 3, then 43. You will get it. Clear? Like this, you will find out. So you can multiply here. Two scenario I told for the partition. Floor, U value already you know, A del T. Okay. If above it is condition, so based on that same scenario you have to take it. Okay. And ceiling. Clear? These all are one category. Next, roof. This is the thickness U A. Okay, del T, equivalent temperature plus correction factor. Correction factor, you know, equivalent temperature you have to find out in this table. So 35 plus 19, you are getting this. All the other value, you know, area, you know, U value, you know. Clear? And for the roof, what all the type of insulation you are giving, that also play a vital role. Like a lot of equipment will be there, like chillers and everything will be there at the roof level. Okay, so you'll have an insulation. So insulation we have to give. That insulation you will find out from the architect. What is the insulation and all those things they are considering for the construction. Clear? Then total Q value you got it. Now similarly for the door, similarly for the door, UA del T, U value already we have for the door. A you know 7 by 321, del T is equivalent temperature plus correction factor. So wall and door almost same. Okay, and window, if you have a glass, that partition, that is one category. So based on this, you will find out here, my correction factor anyhow it is 19, 12, equivalent temperature you will find out 40, and you get this value. Okay. Clear? Next, we have ventilation and infiltration. This is a separate category. We'll discuss tomorrow. So I think you need to practice because a lot of content we discussed. It will be difficult for you to digest everything in one day. Right? You practice this because all are interlinked. If you are not able to understand yesterday's, today's session, tomorrow you will not able to understand. So practice today everything because these all are interlinked. And tomorrow we will complete the manual one. Next week we'll go for the app software based.
From next week, it's you'll tell full software, or again we go through theory.
No, it will be software based. That's what this is the concept. Okay, once you understand, if I go directly to the software, a lot of things that then we're not able to understand.
Yeah. Okay.
Right. So for that reason, first manual, then we'll go for the software.
Okay, sir.
So some terminology is there we'll not able to understand directly.
Software means same AutoCAD or different
No,
software, I
no.
guess.
It is the designing software, which is your hourly analysis program. We'll share you the software you can download and install it.
Okay.
Okay. Fine then. Avan, what about you? Have you understood everything? I think we joined between.
I have done all of this in the past, so that is the problem.
Oh, so you know most of the things. Right? If you know
Yeah.
this, if you know heat load, then most of the things. Anyway, good.
I know, I think I'm a bit confused about software only. I can do the manual one.
Yeah, software part is easy once you understand the manual part. Because of that, I've taken the manual part first. Once you know the manual thing, software is easy, but you have to give the correct inputs. All
Yeah.
information you have to feed to the software, then it will give the outcome.
Okay.
Okay. So from here, find out the Chicago location, search, select the thing, you will get it outside variable temperature, all the parameters, then go to the online psychometric calculator. You will get, you put all the thing, you will get it. Okay, absolutely. Humidity ratio and humidity ratio both are same, dew point temperature, all other parameters. Enthalpy, wet bulb temperature, volume, specific volume, everything you will get it. Clear?
Yes.
What else? Which other assignment do you want to? Now, Vivek, you are asking this point, right?
Yes.
Yeah.
HU and FCU selection.
See, here 120 TR. So if I convert 120 TR into CFM, so 120 to convert to CFM, you need to multiply 400. You're getting this much. So whether you are going to select one number, 18,000 CFM 4 number, or for example, I'll select like 20,000 2 numbers, which is your 40,000, remaining is 32. So 16,000 2 numbers. That way also you can plan.
Okay.
Okay, the configuration you can plan accordingly.
Yeah, but for this selection, I mean, I don't think we have learned how to read the catalog.
The catalog, this can be customized. Okay, this can be customized.
Okay.
You don't have standard catalog for this. But if you Google it, you will get some standard catalog. Okay.
Yeah.
So, for example, you're choosing 20 and they don't have 20,000 CFM. So next they have 22. They will give, if you give 20 also, they will supply you 22,000 CFM. You choose.
Okay.
Okay. Yeah, very interesting.
And like FCU, what about FCU, the fan coil unit?
Yeah, both are same actually, AHU and FCU.
Okay.
If your capacity is more, then it is AHU. If capacity is less, it is FCU. So, and inside, like we have been used some in VRF, we have used cassette unit. Some places we have used adaptable static. Okay, so those things also you can select as per the requirement. Already we have done selection for FCU in VRF.
Yeah.
Here,
Okay. Yeah.
what next?
If you go to chill water piping, a little bit up.
Hmm.
So there you mentioned 2 working plus 1 standby. So
Hmm.
what it means working and standby?
Okay, two working on-stand environments. You have a chiller. Okay, 3 chiller are there, and 2 will be working, and 1 is standby. Like in case of any failure of thing, the standby will operate. That is the concept here. For example, 2 chiller is able to supply the requirement, what all requirement you have. In 1 standby you have to put. If anyone is not functioning properly, it is under maintenance, so other can support you. Getting it? Mukesh?
Yes, sir. So does it matter for diameter of pipe? That
No,
that
that is
that
for chiller, not for pipe.
yeah. So
What does it mean? You have a chiller, chiller, and what configuration you do. If you see, I have shown you one of the video for the schematic. See previous some. Okay, there primary pump and secondary pump was there, and the pump piping it was running to AHU.
yes.
Okay, AHU to chiller, and from chiller to AHU, those things you need to consider and find out the pipe size.
Okay.
Fine, we'll catch up tomorrow, same time.
Okay. Thank you, Rakesh sir.
Yeah,
Thank you.
thank you.